Welcome back. So it is worth to note that when you create a subnet, there is a default network access control list that is created, and it is associated with the first subnet that you create. And the network ACL, inbound and then outbound rule, allows all traffic by default. So our architecture will look like this: a network ACL that controls the public subnet, right? And it allows inbound and then outbound traffic by default. That is all inbound and all outbound traffic by default. So back to our management console, our test instance is now ready. So we'll note the IPv4 of the instance. And now let's go to our PuTTY. Let me clear this screen. And I'll ping the IP address, the private IP address of our test instance, right? So this is our test instance and this is the private IPv4 address. And let's see. So it means that so you can see ICMP, right? Communication is going on. It's able to ping. So what we are going to do, we'll leave PuTTY opened, right? And so let me just place them side by side this way. So you can see communication is still ongoing. Let me resize it a little. Yes, awesome. And what I'm going to do is I'll configure my network access control list. You know, we configured security groups to allow all ICMP traffic. Now I'll go to my network access control list and deny all ICMP traffic, and we'll see what happens. We understand that security groups work at the instance level, while the network access control list work at the subnet level. So it means that anytime a traffic is coming in, it will hit the network access control list before the security group. So even if a traffic is allowed in the security group and is denied, the same traffic is denied at the network access control list, that traffic will automatically be denied. So I will navigate to VPC again. And from VPC, I'll navigate to network access control list. I'll select my lab network ACL and I'll edit the outbound rules, right? So I'll edit rules. So this is 100. This rule, I'll give it a precedence of 80 because all traffic are being allowed on row number 100. Okay, 100. So it means that even if I set this at 110, it will still allow, because 100 will have a higher order than 110. Okay, so the rule number for this will be 80, and it will stop all ICMP IPv4 traffic, and the destination address will be that of the test instance private IPv4 address /32. That means the exact address, and will deny, right? And immediately we save this, you realize the ping will stop. So this simply means that traffic is not being able to move from the private subnet to the test instance, and therefore the test instance is not able to also give response to the private instance. So that is how the network access control list works. Even though this kind of traffic is allowed at the instance level, because traffic will first hit the private subnet before it hits the instance, that traffic will be denied when it is denied at the network access control list. So let's go back to the architectural drawing and we'll do some illustrations. Okay, so we have this as test SG, and we have this as our test instance. Great. So we had traffic moving from here to here, right? And we also had traffic moving from here to here, this way. Let me put it here so that we'll be able to see it well. Nice. So we had, let me bring this somewhere here. Okay, awesome. So we had traffic moving from here to here, and then we had traffic moving from here to here. But what is happening is that we have now gotten rid of this. Okay, so what is happening is that this traffic has now been ceased. So there is no traffic going from here to here, going from the private instance to the test instance. Okay, So let's go back to the network ACL, and I'll just remove this outbound rule. And you have to also note that because I gave it a lower number, so this rule will be evaluated before this rule will be evaluated. Supposing I had given this 110, so 10, okay, and let me save, you should see the ping utility working. So you can see it has started working, because what is happening is that, let's edit the outbound rule again. What is happening is that the row number, the all traffic row number has a lower row number, and it has the higher priority than this one that has the largest or the biggest priority. I mean the biggest row number, this 110. So this rule is evaluated. So once this rule is evaluated and it's allowing, that should be it. Okay, so even though I've given this number, it doesn't do anything. You get it? But immediately I change it to 80, the ping utility should stop again. And you can see this has stopped. It stopped as what? 637. Now let me edit it and remove it totally. So I'll remove this rule, right? Or I can just change it to allow, right? Anyhow, any way that I want it, but I'll remove this altogether. And you can see from it continues counting. Okay, so that is the beauty of security at all layers. So let me do this again. Awesome. Let me send this here. Nice. Okay, so this is now nicely done. So this is the architecture that we have so far. Okay, so I can just exit out of this, and we have been able to test our connection. So I can close putty now and put this in a maximize this. So this is the architecture that we have ended, or we will end with. Now I'll explain the statelessness of network access controllers and the statefulness of security groups. Now they say security group are stateful, which means that anything that leaves is being remembered. So on its way coming will be remembered and will be allowed in without us specifically even configuring to allow that traffic inbound. But with network access controllers, whether the traffic is allowed or denied, it will still be evaluated at the point of entry and at the point of exit. So even though we have allowed all traffic outside the security group, you remember when we configured the network access controllers to deny outbound ICMP traffic, the ping utility stopped. So that is how the network access controllers works. So let's take a school for example. You are a student, you are coming in, the security man will check you before you enter, and before you go out, the security man will check your ID again. On your way back, the security man doesn't remember your face. He will have to check your ID to confirm that you are a student. But there is also another part, that is the security group, that says that okay, immediately when you are going out and then you are a student, when you are coming in, as far as they remember that you are a student, you are allowed to come in without any trouble. So that is just a short explanation. So this brings us to the end of this demonstration, and I hope you like it and it was educative. Thank you for watching, and I'll see you in another video for another lab exercise.